the x-intercepts? Okay, perfect. Next question, the y-intercept. 0, 1, I agree with the y-intercept. Excellent, thank you. Number 6, intervals on which f is increasing. Is f ever increasing? Is the function ever increasing? So it's increasing, it gets to a maximum, it's decreasing, it gets to a minimum, it's increasing, it gets to a maximum, it's decreasing to whatever. So increasing and increasing. So the function is increasing on negative infinity till, remember, we do not look at the y values. We're talking about the trend, where the trend exists. We do not care from which value till which value. We're talking about the trend. So between negative infinity and negative 2, union 0 to 3. 7, the function is decreasing on, excellent, negative 2 to 0, union, yes, 3 to infinity, awesome. Values of x for which f of x is less than or equal to 0. Okay, let's analyze this. You didn't even hear the question. Let's talk about this function. Let's take a look. Ready? Okay. Would you agree if I said that between negative 4 and 4, all function values are positive because the function is above the x-axis? So if I pick negative 1, I will read a positive y value. If I pick 3, I will read a positive y value. If I pick negative 3, I will read a positive y value, and so on and so forth. Would you agree? Yes. Would you agree that if I pass 4 to the right or negative 4 to the left, if I pick this value, the y value will be negative? I can have to extend it to determine it, but it will be negative. If I pick 5, again, I will read a negative value. If I pick 100, I will still read a negative value. So then between negative 4 and 4, I will say the function is positive. But between negative infinity and negative 4, union 4 to infinity, the function is negative. Very good. So let's write that down. So here's how I wrote it for you, and I'll show you this. F of x is less than or equal to 0 for x in the interval negative infinity to negative 4 closed with a bracket, union 4 to infinity. Oh, I know, you're going to see everything. I just don't want to go in and out. I'm going to show you everything in a minute. Okay, next question. The numbers at which f has a relative max. So let's analyze this. Right now I'm asked where the position of the maximum is. I don't care about how much the maximum is, but at which x value I have a maximum, or at which x value I have a minimum. So what would you say? Where is there a maximum? At x equals negative 2 and x equals indeed 3, f of x has max. Good. Next one. Find the relative max. Now I'm asked, how much is it? I'm told now the maximum is at negative 2 and it's found, another one is found at 3, but now I'm asked, okay, how much is it? Now give me the maximum. So what will you say at x equals negative 2? At x equals negative 2, you will say f of negative 2 is 4. That is the max, or the local max. And at x equals 3, f of 3 is 2, and this is also a max. And that's the max value. Okay. F of negative 2. They're asking us to find f of negative 2. I imagine what? Or I simply draw what? To find f of negative 2. I draw a vertical line at negative 2, and I read the y value, and f of negative 2 is, so that's number 11, f of negative 2 is 4. Perfect. The values of x for which f of x is 0, we already know those. F of x is 0 for which x values. It's the same thing with the zeros of the function, and the same thing with the x-intercepts of the function. When x is right, these are the x-intercepts. Two more questions. The values of x for which f of x is 0, we just determined that 0. Okay, sorry, just one more. Is the function even, odd, or none of the above? None, not symmetric. That's it. Perfect. Any questions? Okay, let me show you the notes I took for you. Okay, so the function was, the graph represented a function by the vertical line test. The domain was indeed all real numbers. The range was negative infinity to 4. The x-intercepts were negative 4, 0, 4, 0. The y-intercept is 0, 1. The function is indeed increasing between negative infinity and negative 2, union 0, 3. The function is decreasing between negative 2, 0 and 3 to infinity. The function is negative for any x value between negative infinity and negative 4, union 4 to infinity. So it's negative or 0. At x equals negative 2 and x equals 3, the function has max. At x equals negative 2, the max is 4. At x equals 3, the max is 2. Let me know if I can go back to the next page. Any questions? Any questions so far? Bless you. Is this okay? Can we move on? Perfect. Okay, so I also wrote that f of negative 2 is 4. Then the x-intercepts are the zeros. F of x is 0 when x is negative 4 and 4. Is that okay so far? Yes? Okay, and the last one, the function is not symmetric. It's not symmetric with respect to the origin, which would mean odd, and it's not symmetric with respect to the y-axis, which would mean even. Last topic here, before we, on Wednesday, we do 2.3 and 2.4. We'll do them together because they mean the same thing. They're talking about lines and linear equations, and linear functions, sorry. Is how to graph a piecewise defined function. I know I have 10 minutes. I may be able to finish in 10 minutes or not. For the first example, you know I talk a lot. The second, the third are much easier. Okay, piecewise defined function. What do you think a piecewise defined function represents? And if you could give me an example from real life situations. obviously, a piecewise defined function is defined in pieces. It doesn't have just one function. You may have two, you may have three, you may have four, you may have any number of functions. So it's defined in pieces. Pieces of what? Pieces of the real line. So let's say between negative infinity and negative 3, it's one function. Between negative 3 and 5, it's a different function. Between 5 and infinity is a different function. It's still one function. They are not overlapping or anything, but it's defined in 3 pieces. To the left of whatever, in between. If it has only 3 branches, you may have 4, you may have 5. So a piecewise defined function is defined in pieces. Now, can anyone give us an example from real life situation? Why wouldn't they even bother with this? And I can just give you a hint. Every year, that's what it is. For an income between, I'm just making up numbers, I don't know. Between this and this, 20%. Between this and this, 25%. Between this and this, 30%. That's a tax code. It's many functions. It's a function that is piecewise defined. So for people between income here, they have a certain function. People here, a different function. People here, a different function, and so on and so forth. That's what a piecewise defined function represents. So let's see an example. On page 252, I'm going to choose a simple one. Maybe we can finish it. If not, we're going to look at, okay, 64. We have f of x. So again, on page 252, f of x has 2 pieces. One piece is x plus 2. The other one is x minus 2, comma, if x is less than negative 3, and if x is greater than or equal to negative 3. Okay. We're asked to graph this function. I like a particular method to present, which I think it's easier to understand. But if you go to the math lab and they show you a different method and you like that method, please use that method. Adopt my method only if it's better for you. If not, you will not hurt my feelings, I promise. So every time I'm asked to graph a function, I will always start by finding the domain. That's my first concern because I don't know what numbers to plug in. So that's always our first concern. If we are asked to graph a function, we have to find its domain. Okay, I'm going to replace this. Don't erase it like that. I'm making a point. With an interval notation. Can anyone give us the interval notation that replaces that? Infinity to negative 3. Less than negative 3 means negative infinity to negative 3 with a parenthesis. The same thing, I would like to replace this by what it equals to. Can anyone give us the interval for that? Excellent. So negative 3 to infinity. Now I'm interested in the domain of the entire function. The first piece is here. The second piece is here. But I want the domain of this function. Look at this and look at that and tell me the domain. Do you all agree that this function has no gaps? We have everything to the left-hand side of negative 3. We also have negative 3. And we have everything to the right-hand side of negative 3. Do we see that? Is the function defined on all real numbers? Yes? Perfect. So now I will start a table where I put the domain. Now let's go back to the function for a moment. We will need some x values, of course. But there is one in particular that is extremely important that must be in the table. Why negative 3? Perfect. Why? Why I can't get away from this negative 3? Of course, 0 will be in the table. But why negative 3? Because something major happens there. The function changes from this function into this function. That's where the threshold is. On this side of -3, one function. On this side of -3, a totally different function. Perfect. Good. So accordingly, right underneath -3, in this particular order, I will copy these two symbols and they will be touching each other. So exactly under -3, I copy the parenthesis opening this way, and I will copy the bracket opening this way, like this. I'll explain why in just a minute. Now please tell me which function we use here and which function we use for those x values. Which function? You can say, but it's right there under your nose. Yes, true. But it's safer if we put it on the table. And those branches may intentionally not be in the correct order. So that's why I have to make sure that I put between -infinity and -3, which function? Very good, awesome. And between, I know it's silly to ask again, it's the other one. So between -3 and infinity, I will have to use x minus 2. What type of functions are these? Both are linear. Very good. Okay, so I'm going to plug in numbers to the left of -3. So I'm going to plug in, let's say, -4. So please plug in -4 and tell me what is the y value when x is -4. Perfect. Please plug in -3, and you should say, no, I won't. Because I'm asking you to plug in -3 in this function, but there is a parenthesis here. So I cannot really plug in -3 here because -3 is with the other piece, not with the top piece. But I'm going to say, just do it for me and I'll explain. So when you plug in -3, what do you get inside the parenthesis? -1 indeed. I'm done with the left branch. Now please plug in -3 and tell me what you get. -5 inside the bracket. Please plug in 0 and tell me the y value. And this time, because it's an x-intercept, I will plug in 2 because I get 0. Let's graph this function from left to right. Please give me the first ordered pair. We'll have other examples. Don't get scared about this at all. It's not a difficult situation. We'll have many more examples. So please order pair from left to right. 1, 2, 3, 4. 1, 2. I got the first point in. Next one. Good. Now I have to decide what type of point is this, because I'm not really allowed to plug in -3. So what kind of, exactly, it will be an open point. I crossed on the other side. Please give me the next ordered pair. I'm not looking back. The next ordered pair would be, what type of point will be -3, -5? It will be a close point. The next ordered pair, 0, -2, it's right here. And the next ordered pair is 2, 0, it's right here. And this is the other piece. And this is function f of x.